standard 8.G.5 is about angles. It's the only standard we have about angles, and it uses several different types of angle relationships. Number 2, in the figure, C is parallel to D. Talking about these two lines. What are the measures of angle 7 and angle 8? So I'm going to start here with angle 7. I noticed that the only angle that it's given is 75 degrees, but these two angles, angle 7 and the 75 degree angle, they are supplementary, which means they add up to 180 degrees. So I can use that fact and say 180 minus 75 equals 105 degrees. So the measure of angle 7 is 105 degrees. Now I want to look at the measure of angle 8. So here's angle 8, and we already had this angle across from it with 75 degrees, and I noticed that they are across from each other on two lines that intersect, and so these are called vertical angles. And we know that vertical angles are congruent. So the measure of angle 8 is the same as the 75 degrees, so it's 75 degrees. Number 3, in the figure, D, E, and F are parallel lines. What's the value of X? Well, when we have parallel lines, that means that there are only two angle measures in the entire diagram if all we've got is a set of parallel lines cut by a transversal line. And so looking at these angles, I know one is 60 degrees, and then I know one is x minus 30 degrees. I can tell that these are obviously not congruent because 60 degrees is an acute angle, it's less than 90, and x minus 30 we can tell by looking is obtuse, it's greater than 90. So that means these are supplementary to each other. They add up to 180 degrees. So 60 degrees plus x minus 30 degrees equal 180 degrees. And I could just drop that parenthesis because I would have an invisible 1 right here, which 1 times any term is going to keep it itself. That's the identity property. So 60 plus x minus 30 equal 180. 60 minus 30 are like terms. They combine to get positive 30. So we've got x plus 30 equal 180. And then we'll subtract 30 from both sides to get x by itself and get x as 150. And that's what it asks for. It asks for the value of x. X is 150. Number 7, in triangle PQR, what is the measure of angle Q? Well, we notice immediately that there are 3 angles within a triangle. So I'm going to add them all together. 9x plus 2 plus 4x plus 10 plus x, and all together those add up to 180 degrees because of the triangle Sum Theorem that says they add up to 180 degrees. And so I could just drop these parentheses because there's just invisible ones that are being multiplied outside of each of these. And we'll combine like terms. We have 9x plus 4x plus x is 14x. And then we have 2 plus 10 is 12. And those add up to 180. And now we just have a little two-step equation. We're trying to get 14x by itself. So we'll subtract 12 from both sides of this equation. And we get 14x equals 168. Then divide both sides by 14 to get x by itself. And 168 divided by 14 is 12. So we now know x that's not what it's asking for, but that's a step closer to the answer. We're looking for the measure of angle Q. So now we're going to go over here and say, the measure of angle Q is 9x plus 2. So 9 times x, which is 12, plus 2. And 9 times 12 plus 2 is 110. So we get that the measure of angle Q is 110 degrees. Number 8, what are the measures of angle 1 and angle 2? And at first glance, when I'm looking at this problem, I see multiple triangles within the diagram. And so I'm going to start by looking at angle 1 and seeing what I can determine. I have this angle 1. I notice that it's inside this triangle. And this triangle, when a line of it is extended, it forms one exterior angle. So I've got this exterior angle, 117.5. I've got this interior angle 1 and this interior angle 21.6. So that's two remote interior angles. And then we have one exterior angle. So I can use exterior angles theorem. And it states that the two remote interior angles, that's the measure of angle 1 plus 21.6 degrees, add up to a sum that would be an exterior angle, 117.5 degrees. And so since these are the two interior angles that are far away from it, we can plug them into this theorem. And so now we just solve. We'll subtract 21.6 from both sides. And we get that the measure of angle 1 is 95.9 degrees. And so now I'm going to plug that in right here for 1 is 95.9 degrees. Now, I'm going to look at this other diagram and notice I have got this interior angle here, 39.1 degrees. It's part of this triangle. And I have this angle and this angle are remote interior angles to this 95.9 that's exterior. So we have 39.1 degrees plus the measure of angle 2 add up to 95.9 degrees. So we'll just subtract 39.1 from both sides and get that the measure of angle 2 is 56.8 degrees. And that is answer choice B. Both of these use the exterior angles theorem.